Hello everyone, we are Group SO3 and we are proud to present our new innovative product, Laddify. We are a group of electrical and computer engineering students, and from left to right we have Tyson, Brian, Horace, and Andrew. Our goal here at Laddify is to create a product that has the ability to work natively with ladder logic PLC programming languages. Laddify works with all sorts of work environments that can export code into XCF files, such as Schneider Electric's Control Expert. Just for some background, PLCs are a type of industrial computer control system that monitors its input devices and uses its programming to control the states of its output devices. PLCs are widely used in industrial sectors such as manufacturing and energy. Many of the organizations in these sectors recommend using code coverage testing tools. Code coverage analyzers are a commonly used tool to verify code and ensure code readiness. Problem is, there is no code coverage analyzer that currently works natively with ladder logic. For our project, we set out to resolve this issue. We first would have to convert all of our ladder logic files into XCF files so we can read and run through the code using Python. Our final product aims to display all logical equations and display which Boolean values are mutated.
Now, first off, let's discuss why we deem that this issue is so important to solve. Laddify aims to provide a safer working environment for workers in manufacturing plants and power generating facilities. Laddify achieves this by providing a reliable code coverage tool for engineers to check their safety, critical code in ways that are currently cumbersome. Both the energy and manufacturing industries are a very important part of our everyday lives. These industries use PLCs, which are an essential in safety-related systems for producing goods and for protecting the flow of electricity. Laddify can add by providing an automated program to analyze the code in the PLC used to further ensure reliability and safety to these industries.
In order to see our vision through, we divided the workload into technical modules, being the GUI and the code analyzer. First, let's talk about the GUI.
When it came to the creation of the GUI, we wanted to have a simple design and be straightforward to use, while also being functional. We ensured that the GUI was able to browse, open, and view XML files, with the function of also analyzing and verifying the code. The second and main bulk of the project was the code analyzer itself.
For the code analyzer, we aim to first navigate through the XML file to locate all the variables and store each variable in a custom data structure. Now, with the ability to navigate through the XML tree, we are able to locate all the logical program information. This information is then captured within a matrix with custom variable types. Using this, we are able to form logical expressions via recursion to represent all of the variables within the ladder logic code and produce the output results. This is then run through a code coverage program via Python so that we are able to display which code has been executed.
Next, we'll have a short demo of how Laddify works. Here, we have our sample ladder logic program that we are testing. Next, we'll open our XCF file using Laddify's user interface. You can also see that we can open the XML file that it generates. Now, we generate the logical equations using the Generate button. The Test button allows us to open the File Tester window, where we can alter the input variables and observe the resulting outputs. Finally, the Analyze button will open up our code coverage tool. Here, we can observe the code coverage achieved by the program displayed at the top of the window. As a side note, we have a user manual under the Help drop-down. Now that you know what Laddify is all about, feel free to try Laddify for all your ladder logic needs.